For this problem, we're given a piecewise function, meaning there are three different parts to its definition, and we'd like to figure out one- and two-sided limits for these particular values. One approach you could take is by actually trying to sketch a graph of what this piecewise function looks like. So I'm going to do that down here. And it just has to be a somewhat decent sketch. It doesn't have to be perfect. It just has to indicate what's happening around the points 2 and 4. Probably also 0 and 5. To start with, I see that the function g of x is equal to 1 if x is less than or equal to 2. So what this is telling me is that at 2 and less than 2, the function takes on a value of 1. So 1 is a horizontal line, and it stops when you get to x is equal to 2. And because there's an equal sign at 2, I'm going to put this closed circle there to indicate that at 2, it takes on a value of 1. And if you're less than it, it's always 1, so I will put this arrow to indicate that it's going to the left forever. Now, between 2 and 4, and not including either of those points because there's no equal sign, the graph is going to be 8 over x. 8 over x is a rational function, so it's going to have kind of like a curve to it, and I think the graph is going to decrease. So what I'm going to do is see what this thing would actually equal at 2 and put an open circle there. I'll then do the same thing for x is equal to 4. So if you were to put 2 into this expression, 8 over 2 is 4. So at 2, 4, I'm going to put an open circle like this. So that's kind of like where the graph is starting. And then as we move from 2 to 4, I want to know how much the graph drops down by. If I put 4 in place of this x, 8 over 4 is equal to 2. So it starts at 4 and it actually ends at 2. There's no equal sign, so again, I'm going to put another open circle here. So it's not linear, but it decreases like this. It has kind of a curve to it. So the last thing is, for the last part of our definition, if 4 is less than x, it's this linear function, 6 minus x. That's a line with slope -1, meaning that it is decreasing. So likewise, at 4, I want to know where to begin with this function. So I'm going to put 4 in place of this x, and I get 2. So its starting point is actually where this one ended. Again, as there's no equal sign here, I'm going to leave it this open circle. So it starts here. It's decreasing with slope -1. So I'm going to draw in this as my equation. It's this linear function. So, I mean, not a perfect sketch, but it definitely illustrates what is happening at 2 and 4, but also at 0 and 5 as well. Okay, so now that we actually have this graph, we have this picture, I think we can figure out the one- and two-sided limits starting at 0 and ending here at 5. Let's look at x equals 0 first. So that is, if we're thinking about one-sided limits, I want to know the limit as x approaches 0 from the left of g of x, and also, what is the limit as x approaches 0 from the right of this function? If those two limits are the same, then we can say there is a two-sided limit equal to that one value. Okay, if we're focusing on 0, that means we're looking right here. Okay, there's no split or break or any holes that appear in the graph. As we approach from the left, it's always equal to 1, and as we approach from the right, it's always equal to 1 as well, and that's because we're looking at this part of the definition. So just by using this graph, I know the limit from the left is 1. I know that the limit from the right is 1. So in this instance, we can say altogether that there is a limit as we approach 0, and it is also equal to 1. So I'm seeing for 0, because it wasn't referring to a 2 or a 4, it actually was a relatively simple answer. Okay, let's check out what's happening at 2, because now here I'm seeing there's a split in the equation, so I'm thinking something different is going to happen. Okay, so what is the limit as x approaches 2 from the left? What does that equal? if anything? What about the limit as we approach 2 from the right? I think they're going to be different, and I think that means the limit overall is not going to exist. Okay, if I look at 2, and I think of approaching from the left, I'm talking about this part of the function, it's definitely going to be equal to 1. So I can see from the graph that the limit is 1. However, if I'm approaching 2 from the right, here I see that the graph is going up and it keeps getting closer and closer to 4. So here the limit from the right is 4. These are not equal. These are two different values. So I'll say, those are definitely different. And what this means is the two-sided limit, the limit as we approach 2 of g of x, I'll just put does not exist. So the function's defined there, it equals 1, but there is no limit overall. Okay, moving on to 4. Again, if I look at 4, okay, something odd seems to be happening here. There's a hole in the graph. Let's see how this affects things. For that one, okay, so that's the limit. I'll say as x approaches 4 from the left, and then the limit as x approaches 4 from the right. All right, let's see what happens. As we approach 4 from the left, we're on this part of the function, and even though there's a hole here, that does not matter. I'm definitely getting closer and closer to y is equal to 2. All right, so that's good. The limit from the left exists, it equals 2. Now the limit from the right as we approach 4 is actually also going to the same spot, which has a y value of 2. So even though that there's a hole in the graph, that does not affect things in terms of the limit. The limit as x approaches 4 of this function is defined and in fact is equal to 2. All right, we got one more here. That is the limit as x approaches 5. And again, we'll consider it from the left, and we will consider it from the right. Are these going to be the same? Are they going to be different? What's going on here? So here we have 5. It's referring to this part of the graph. I can immediately see that just like when we were talking about 0, there's no split, there's no hole or a function that's defined somewhere else. As we approach from the left and the right, it's going to the same location, and that location is y is equal to 1. So I know the limit from the left is 1, the limit from the right is 1. We can say overall that the limit as x approaches 5 of g of x is 1. So these are all the limits, and that's everything for this question.